Bienvenidos, Ushamandid, and welcome to this HUD 8 techtorial on Cisco's Enterprise Networking Security and Automation, or ENSA, CCNA version 7 curriculum. We are going to wrap up the ENSA course, and this is the final packet tracer activity, which is 12.6.2, our troubleshooting challenge, part 2. And so what we need to be looking at here is the diagram that we completed in the previous activity, 12.6.1, because the topology is exactly the same. However, now we've had issues introduced into the network. So let's take a look at the network we're going to be working with here. It's identical in physical configuration as 12.6.1. And if you haven't completed that activity yet, 12.6.1, that's an activity you're going to have to complete in order to be able to effectively troubleshoot this topology. Now, here's the background scenario. We're going to have some addressing configuration issues, some interface activation issues, routing, NAT, among other things that could be wrong in the network. The passwords are the same, and here is our goal. All hosts should be able to ping each other and the internet server. Now, we've got a little table down here where we can put in the device, the issue, and the action we took to fix it. And so there's a multitude of troubleshooting approaches that we could take in order to try to troubleshoot this. We could do an ad hoc approach and just start logging into devices and try to figure out what's going on. When you have an environment where you don't know what the issue might be, or where there may be multiple issues, I'm a huge fan of follow the path. So pick one of the PCs and then follow the path of that PC to see where it can go and what can it get to. Now, if we knew what had been done. For example, let's say last night the junior network engineer had OSPF changes they needed to make on the hub router. And then we come in and PC1's not able to connect to the internet server. There's probably a pretty good chance that it was something related to that change that was done by that network engineer, and then we could get on the hub router and see. However, we don't know what the problem is here, and that's why it makes it difficult to kind of do an ad hoc approach and just start hopping onto random devices, because we're going to be all over the place. So let's start with PC1 and let's dive in here. And while I'm pulling this up, and we'll give ourselves some more space, let's go ahead and take a look at the IP configuration. And it looks familiar, but let's refer back to the diagram that we had created in order to document this environment. And you can see that having something like this, the diagram completely filled out and documenting the working environment that we had, we should now be able to use this diagram to make it much easier to troubleshoot things that could be wrong. So we can see 153 is the IP address, 192.168.1.0/24 is our subnet here. The switch is 252, and the router, the branch 1 router, is .1. So let's go ahead and come back to the activity, and let's close this out. And so let's test the connectivity right out of the gate here. And again, I'm going to follow the path. Can I get to the switch? 168.1.252. And we should probably drop the first packet, an ARP request, address resolution protocol. That should time out, but I can get to my switch. Again, if everything is working as it should, I can get to that switch. So I can ping the switch. Well, what about my default gateway? 192.168.1.1. Okay, pretty cool. I can get to my default gateway. Well, what comes after branch 1, my default gateway? Well, it's the hub router, which is 192.168.0.1. So can I get there? 192.168.0.1. So I can reach the hub router, and that's a good sign. What about going beyond the hub router? Let's go ahead and try the internet server real briefly and see, hey, maybe I can make it all the way out here. In PC1, there are no issues that are going to impact PC1. So 203.0.113.27. And I think what we're probably going to see here is that this is not going to work. I would be surprised if it does, because again, they've kind of alluded to the fact that we could have some routing issues, but more importantly, we could have some NAT issues. in our way. And you can see we do have a completion percentage down here. And so that's not working. What about another PC? Let me try to get to this PC over here, which is going to be 192.168.4.115, and that's PC3. So can I get to 192.168.4.115? In other words, can I get to the hub router and then successfully have the hub router get me down to this PC? And so as you can see, it looks like the issue might be on the hub router, at least from PC1's perspective. So let me Control-C this here. So now let's take another troubleshooting approach. Let me trace route out to the 203.0.113.27. So let's see, if I try to get to that internet server, where can I get to? Well, it just so happens I can get to the hub router, and that's as far as I can go. What about trace routing over to 168.4.115? How far can I get? I can get to the hub router, and I can't get any further than the hub router when trying to get to that network, the 192.168.4. So we can assume at this point that there's definitely something going on the hub router. Well, how do we get there? Well, let's go ahead and let's jump to 192.168.1.1. Cisco is our VTY password. The privilege exec password is class, and that puts me under the branch 1 router. So I know we're running OSPF. So what about a show IP route here? What kind of information are we getting? Well, we are picking up that default route, right? So we know that the hub router is originating a default route, so we're seeing that. If I take a look here, do you see the 192.168.4? Right? I don't see an OSPF learned route for that network. I do see the transit segments on some of the other serial links in the environment, but I don't see anything for the 4. So let's take a quick look here. We'll say show run, and we'll take a look at our OSPF configuration section. And it's the same as it was the other day, right? When it was in a working configuration, we've got our network statement here for the 192.168.1, and then we've got the network statement for the transit link, or that point-to-point serial connection to the hub router. And again, a few things that we talked about in the reflection questions yesterday. What could we do? Well, we know we're using VLAN 1 for PC1. We would probably change that. We would use port security, right? We would put spanning tree toolkit features like BPDU guard, port fast, root guard on the host-facing ports. So here, if I just real quickly get into global config and say router OSPF, 10, we're going to say passive interface gigabit Ethernet. And actually, let me double check. Do show IP interface brief. We'll say passive interface gigabit 000 because there's no OSPF speaker out there, but yet we're still advertising that network. Maybe you change the router ID, right? So again, just giving you an idea as to some of the things we covered in the reflection questions, and I'll go ahead and say write mem, and we'll save our config. So now we're going to telnet over to that hub router, 192.168.0.1. And I spelled telnet wrong. So let's make sure we get that spelled right. There we go. Cisco's our password. The enable password is class. All right, so here we are on the hub router. So I'm going to say show IP route right out of the gate, because one of the things I'm most interested in is, do I have a 192.168.4 network? Am I learning that? And I'm not. You can see the static route is here that should get me out to the internet server, right? And if I was to say show IP OSPF, OSPF neighbor, you can see that I've got, or I have my OSPF adjacencies with the router at 0.2, which is the branch 1 router. And let's see here. You can see we've got 3 adjacencies. However, take a look. We should have how many? We should have 4. right? So it looks like I'm missing an OSPF adjacency. And you can see here, this link is the 192.168.0.13 and 14 are the IPs. So we've got the 14. You can see I've got one for 10 and one for 2, but I don't have one over here. Let's see, for the, it looks like the 5 and the 6. And so, and when I say 5 and 6, I'm talking about the IP addresses we have on the interfaces. So we notice immediately here, we could be missing an adjacency here with branch 2. But again, let's kind of stay focused over here. And we're not getting, on the hub router, we're not receiving an advertisement for the 192.168.4 network. We are for the .3. So something I might try is to go back to PC1 and see, can I get to 192.168.3, and it would be 3.50 over here, right? So we know we can't get to the 4. So let's go to the factory router, which would be .14 here. So can I telnet to 192.168.0.14, and I'll say Cisco, and we're on the factory router. We'll go from user exec to privilege exec with class. And the first thing I'm going to say is show IP OSPF neighbors. So I do have a full adjacency, right? And let's say show IP route, and let's see what we're receiving here. So we are getting that default route. I'm seeing the .5, I'm seeing the .3, and the .1 is OSPF Learn Networks. But let's go ahead and say show run. And let's come down here a little bit further to our OSPF configuration section. So we look at the factory router, we notice that there's a network statement for the /24 for the 192.168.3. We have the network statement to facilitate the OSPF adjacency with the hub router. But if I say show IP interface brief, you can see we've got gig 001 here, and take a look at the status, right? And again, I just noticed that the status on this is down. So not only is there no network statement for the 192.168.4, the interface is actually down. So let me go ahead and say show run, and let's take a look at this whole config here real quick. Let's see the gig 00 interface. You can see that's the connection to the switch on gig 000 for the 192.168.3. There's our connection to the switch, and it is shut down. So let's immediately annotate over here, right? So device would be factory. Issue is the gig 001 interface is shut down, and my action, well, that's kind of straightforward. We're going to go into interface gigabit Ethernet 001, and I'm going to say no shut. And we're going to bring that interface up. Now, the challenge that we still have here is that the interface is up. However, are we going to be advertising that network? And so let me do this. If I was to pull up, and let's take a look at our diagram here. Let me pull up. Branch 2 doesn't even have an adjacency. So let's pull, PC2 is not going to work. I'm afraid we're going to have issues because I'm basically going to show you without trying to log all the way back out of all of these connections. Well, let's remember, we saw that we do not have an advertisement in OSPF being received on the branch 1 router for the 192.168.4.0/24 network. And we know the reason for that, and I'll say begin OSPF. We know the reason for that is that there's no network statement. So there's two ways that we could address this. I'm already in the interface. What about an IP OSPF 1? And actually, let me confirm that. I think it's 10. So I'll say IP OSPF 10 area 0. So I don't have to do a network statement. I can do the IP OSPF command under the interface to make that advertisement. As you can see, we are at 20% here. So it looks like we are getting some completion points for what we just did. So let's save our config. I'm going to log out here. I'm going to log out of the, and actually on the hub router, we'll say show IP route, because now we should see the 192.168.4 network being advertised, and we do. So if I go all the way back out, show IP route, does the branch router see it? It does. And so now if I go all the way to my PC, can I ping 192.168.4.115? And when we take a look at this, let's see what happens. And the first request times out, but then the connectivity works. All right, so we've got connectivity from PC1 to PC3, I believe. So now let's check our connectivity to PC2. So now let's go ahead with PC1 and let's attempt to ping some of the other PCs that are in the environment. So if we go back and take a look at our omnigraphal diagram, let's try to ping 3.50, which is PC2. So we'll say ping 192.168.3.50. And we'll see if we have connectivity there. And while that is figuring itself out, let's try 5.227 and 5.83. So we have connectivity there. So we'll try 5.227, and then we'll give 5.283 a try in order to see if we can make it over to PC5 and PC4, and then we'll try PC6 and PC7. So we'll try 5.83. So 5.227 is not working. So 5.83. Let's give that a try. And what are 6 and 7? That's 267 and 248. All right, so 83 worked. So we make a little note, right? We were unable to ping PC5. And so we're going to swing back to PC5 here. And let's try 267 and 248. So we'll say 2.67 and see what happens. And then try 2.48. And again, you know, we make a little note on our notepad here that says we had an issue getting to PC5. So something over on the PC5 side may be an issue. And we're seeing the same thing here with 267. So PC7, and we'll try 248. And so we say PC5, PC7, and possibly PC6 could have some challenges. And so it does look like we've got a problem getting to PC6. And so we took a look here at PC1 and everything looked good. And we were able to reach PC2 as well as PC3. And so now we've got a problem getting to PCs 5, 6, and 7. And so how should we tackle this? Well, let's go ahead and come over to PC5, and we'll see what may be going on here on PC5, because that is kind of where we're following, not so much the path, but now we're kind of following the problem. And so let's take a look here at the IP configuration. So we see that it's a 192.168.5.227 IP, and that is the IP that we had in our diagram. And it is a /25, so we're borrowing one of the host bits for a network bit. And, well, take a look here, right? We look at the configuration for PC5, and what do we see? Well, that it has no default gateway. So that's going to be a problem. Remember, that default gateway value is there so that when PC5 tries to get to a network or a subnet that it is not locally connected to, this is where all unknown traffic that it doesn't have a more specific route for or know about, that's where the traffic is going to be sent. So let's come back to our diagram here, and this should be pretty simple because, again, we did all the hard work up front when we created this diagram. So I can look at this and see, okay, 192.168.5.227, it's a /25. It's in VLAN 10. And so then over here, when I listed out the sub interfaces, I should say, on the HQ router, what do we see? Well, there it is right there. I've got my default gateway. So it should be 129. So I'm going to come in here and we're going to say 192.168.5.129. and we'll add that value in there. You can see that we just went from 20% complete to 40% complete for putting in the default gateway on PC5. So what we would do here is device PC5 issue missing default gateway action, we add in the default gateway. And so now if I come over here to the command prompt and say ipconfig, we can see that we now have the default gateway value in there. But let's check, can I ping that default gateway? So 192.168.5.129, we've got connectivity, and that's a good sign because again, if we take a look at the diagram here, we've got these 3 switches with port channels between the switches. And so the fact that we can get from PC5 up here to our default gateway, which is that sub interface, tells me that the trunking port here is probably properly configured and the sub interface is probably properly configured. Well, let's go back to PC1 and let's rerun that ping command over to 5.227. And so that was the issue with us getting to PC5, was that it did not have a default gateway. And now that it does, those ICMP echo reply packets know where to go in order to make their way back to PC1. And we could have pinged from PC5, but I wanted to check to make sure, and we'll say 1.153. So 1.153. And you could see we can ping both ways. All right, so the next problem was PC6. And so here is PC6 and 7 that are both up here. We cannot get to these, right? So let's come up to PC6. We'll just take these in numerical order and let's follow the path. Now that we've identified there's an issue getting to PC6 from PC1, and let's click here and let's see what we've got. So the IP address 2.48, let's go back over here and look. And yes, that's correct. And it's a /27. So we take a look here, and is that correct? So a /25 would be a 128. A /26 would be 192. A /27 would be 224. So that looks good. Now we come down, the default gateway is 2.33. So again, we refer back to this diagram where we can see that VLAN 32 corresponds to this subinterface here, which is 2.33. So this looks correct. So what I'm going to do right now is let's run some ping tests here from PC6 to see, can I get to 2.33? And we'll give that a try. We'll close this down. Can I reach my default gateway? Ping 192.168.2.33. So I can get to the default gateway. Can I reach PC7, which is 2.67? Can we get there? And let's see what happens when we go to our default gateway, and it should route that traffic, and it does. And so I can reach 2.33. I can reach 2.67. So there's a good possibility here that we're good to go on the trunk link, but let's check that out. Again, I can reach my default gateway and I can reach PC7, so that's good news. So let's telnet in here to the branch router, which is, we should be able to get there using 2.1. So, and actually we'll go to the switch. That's the next, we'll follow the path to 2.17. So let's say telnet 192.168.2.17. Cisco's our password. To get to privilege exec, it's going to be class. And so here we are. Let's say show run here. Right, let's see what we've got. So you can see fast Ethernet 01 is access VLAN 32. So is 2, 3, 4, 5, and 6. It looks like quite a few of these are in VLAN 32. And then we've got our VLAN 64 hosts. Well, how can I conclusively check to see whether or not the PCs are plugged into the right ports, right? We can get to the default gateway, but let's confirm this. So what about a show MAC address table? And we can see here we're using fast Ethernet 09 and fast Ethernet 020. Well, let's go back to our diagram here. Do we even have that on the diagram? Well, here it shows fast Ethernet 01 and fast Ethernet 012 because when we initially looked at this the other day, that was where those ports fell out. However, you can see here 5971, and that looks very familiar to me as a MAC address for PC6, and 1678. So all we'd have to do is pull PC7 up here, and let's confirm and make sure that we are plugged into ipconfig dash all, and you can see there 1678. So this is in fact PC7, and so what we're seeing there, the 1678, so PC7 is in the right VLAN and it's in fast Ethernet 020, meaning that PC6 is going to be in fast Ethernet 09. And so what I'll do here is, again, these things can change, so we'll come over here and we'll change that to fast Ethernet 020 for PC7 and fast Ethernet 09 for PC6. So that looks good. Let me go ahead and say show interface trunk, because we should have a trunk port here, and we do, and we can see that it's using mode on 802.1q, and so if I was to say show run and we go down to the very bottom here, you can see for gigabit Ethernet 01, we are hard-coded, right? And that's what that mode on means, to switch port mode negotiate. So the other modes you may see are dynamic or auto. Desirable or auto. So we have switch port mode trunk here. So the trunk port looks good. So let's make our way over to 192.168.2.1, which is going to be the branch 2 router. And so we'll go into privilege exec with the password of class. And let's say show IP route over here. And let's see what we see. And take a look. Now this could be problematic. And we saw this early on where we were not seeing the networks. And you can see right here, show IP OSPF neighbor, right? We may have an issue here because this router should be configured with OSPF, and it should be receiving all of the routing information for the rest of the domain, the OSPF routing domain. And so here is the branch 2 ISR 4300. And you can see that we should have serial 010 facing the hub router to get that routing information. So let's take a look. Take a look at the larger config here. And let's check a couple things. Let's first see, okay, there's my connection to the switch. I've got my sub interfaces, all /27s. That information is all correct. So we don't have any issue with our router on a stick config. So here's the serial 010 interface, and it's listed as .17. And so if you take a look, the IP addresses did change ever so slightly. So you can see serial 010 is a .17, it's a /30. So our /30 is correct, but our subnet has changed. And then we come down and there is the OSPF configuration. And you can see that what is the network command that's in here? Well, the network command is 192.168.0.4. Now, that was correct, right? So we can see that originally that's how it was configured. But how is it configured now on that interface? Well, the IP address is incorrect. So there's two approaches that we can take here, and we're going to follow the one that makes the most sense. I could simply change the IP address on the serial 010 interface to what it should be, which is .6. The other alternative is I could leave it as .17 on the interface and change the network statement. However, let's take a look very quickly here at the hub router. And if I come back over to the PC here, and the hub router was 92.01, so we'll telnet to 192.168.0.1, and that should be our hub router. And it is. And let's get into privilege exec with the password class. Now, you may be wondering, why is he coming over to PC1 to look at this? Well, remember, on the PC, that we're currently on, PC6, we're in the branch 2 router, but that IP address is not correct. So it's possible that if I try to telnet to what I think the address should be, which is 192.168.0.5, and let's double check that. You can see 192.168.0.5 is what I believe the IP of that interface is. If that's the case, the fix is clearly to change the serial 010 interface on branch 2 to .6. Now, if that is not the case, I apologize there, the diagram moving around a little bit, I'm checking the hub router serial 011 interface to see, is that maybe .16? Or I shouldn't say .16, but .18. Because that's what I need to see, is which way is this going to get changed. So let's say show run, and we're looking at that serial 011 interface. And lo and behold, the interface IP is .5. And so that tells me, right, that the easy fix here is going to be the one that we pursue. Interface serial 010, 010, and we say IP address 192.168.0 and we are on the branch 2 router, so .6, 255, 255, 255, 252. So we've got 40% completion. We should get some points, and look at that, we go up to 60. So in your device column here, we put down branch 2 router has the wrong, or had the wrong IP address, on the serial 010 interface. And what that was preventing, let's say write mem, what that was preventing, show IP OSPF neighbor, was me, router, branch 2, establishing a full OSPF adjacency with the hub router. So now let's say show IP route. And now take a look at that. Now I'm receiving, as well as advertising into the OSPF routing domain, all of my branch 2 networks. And I'm also getting that very critical default route that has been originated off the hub router. And so now from PC6's perspective, let's come over here to PC1, and let me get these IPs again. So 267 and 248. So let's come to PC1. Whoops, and I did not want to do that. And we'll say exit, and we'll say ping 192.168.5, and let me double check, I apologize, 248. So we'll say .2.48, and take a look at that. So from PC1, I can now reach PC6, and we'll try 267 to see, can I get to PC7, and it works without a problem. So one of the things that we've noticed here is we're now up to 60% completion, which is kind of indicating to me we might have just 2 things that could be wrong going forward here. Now, we addressed the issue on PC5. Let's get onto PC4, and let's run some ping tests here. Again, I'm just kind of jumping around on some PCs we have not been on recently, 192.168.2.48. And so PC3, let's make sure I'm on the, PC4 can reach PC6. What about PC1? So 1.153. And we're good there. What about getting over to 2? Let's try PC2. So that's going to be 3.50. 3.50. Can I get there? And I can. So things look good from the PC perspective. So now, and I'm going to go ahead and do this from PC4, can I get out to the internet server? Let's see, 203.0, and we probably know this is not going to work, but humor me here. Well, actually, hold on a second. So it is working, at least from PC4, it's working. Let me try from PC3. I did not anticipate that was going to work because we know that there's going to be something with NAT. And so what that just tells me right there, that result tells me that the NAT issue might be an ACL issue. Because if PC4 can get out to the 203.0.113.27, PC3 can get out Let's try PC2. And the reason I'm thinking it could be an ACL issue is, remember, we have that ACL, the list, the access control list, that the NAT configuration is going to be, what's that word I'm looking for, is going to be looking at, checking to ensure that we can get access, that we should be NATing. So let's ping out to the 203.0.113.27. All right, so PC2 gets there. PC1, let's say ping 203.0.113.27. All right, so PC1 looks like it might be having some challenges. And while that's working itself out, let's check PC5, 203.0.113.27. All right, so PC5 can get out. What about PC6? Whoops, let's get off the branch 2 router here. Let's ping 203.0.113.27, an IP address I'm not going to be forgetting anytime soon here. And then finally, let's check PC7 and see if I can get to 203.0.113.27. All right, so PC7 worked, PC6 worked, PC5 worked, 4 worked, 3 worked, 2 worked, and 1 did not. And so, again, if all of those other PCs are working, it tells me that we might have an issue on the hub router. So let's go take a look at that 192.0, and I can't remember the hub IP address. I apologize. 192.168.0, 192.168.0.1, and Cisco. And there we are. So we're back on the hub router here. And let me say show IP route, and let's take a look. And what do we notice right away here? So we've got the gateway of last resort is set. So from the hub router, can I ping 203.0.113.27? So the hub router can get there. So let me say show IP NAT translations, and let's see what we can find here. Well, we only see the translation that just took place for this router. What about show IP NAT statistics? All right, and here we go, and we take a look at the configuration for NAT here, and we can see the inside interfaces, right? And so those are the IP NAT inside interfaces, serial 011, 020, and 021. But again, we should immediately notice that there's 3 interfaces listed here. However, there are 4 inside serial interfaces to which this hub router is connected. And we would anticipate that if the requirements of the lab are that we are able to ping to the internet server, that we would be NATing on all of these interfaces. So let's take a look and see which interfaces. And let me provide a little more room here on this for this, what we're going to be doing here. And so let's check and see. So we've got the gig 000 interface. Now we know that's our IP NAT outside interface, right? And we're good with that. That connects to the ISP router. Let's come down a little bit here, and serial 010 connected to branch 1. Well, let me rerun that show IP NAT stat. Do you see where the problem may be here? So serial 011, sorry, I apologize, correction. Serial 010, which corresponds to the branch 1 router, does not have the IP NAT inside command. And therefore, that interface is not going to be checked when packets are coming in to see should this traffic be NATed. And you can see right here it is not listed in the output of the show IP NAT statistics command. So let's do this. Let's fix that. And this is going to be an easy fix on our part. And I don't believe this is going to be worth 40 points. So we probably still have another issue we're going to be dealing with. So interface serial 010. And I'm going to say IP NAT inside. Now you'll notice the completion percentage jumped to 80. So what we want to do here is our device is the hub router. The issue, the serial 010 interface, did not have the IPNAT inside command applied to it. The action, we apply the IPNAT inside command. Now, one of the things you always want to do is we want to save our configuration just in case. And so what this tells me now is we have a single issue remaining in the environment. But let me take a look at the show run here. And I want to come down specifically, and there's our OSPF configuration with the default information originate. And I want to look at the NAT pool because I want to see IPNAT pool is LAN. And source list 1 pool LAN overload. So we're doing port address translation. However, we're using a wide range of addresses here that are available. So we're allowing a ton of outbound connectivity if it was required. So let's jump off the hub router and let's see, can we now ping outbound? So I can ping from PC1 out to the internet server. And so all of the servers can now ping that server. So one of the last checks I'm going to do here, and it's interesting, right? So the addressing configuration looks good. The interface activation looks good. The routing looks good. NAT appears to be good. And we're only at 80%. So the final check is let's ping in order from PC1. Let's make sure we have internal connectivity. So 3.50, 192.168.3.50. Can I get to PC2? And I can't. Can I get to PC3, which is going to be 4.115, 4.115, and everything is good there. What about PC4, which is going to be 5.83, 5.83, and that works. PC5 is 5.227, so 5.227, and that works. PC6 is 248. No issues there. And then we have the 2.67. So we'll come over here and say 2.67. And so all of that connectivity is working. So all hosts should be able to ping each other and the internet server. And we've proven that this works. All right, hold on one second here. I'm just reading through to make sure from the PCs access the devices. All right, so everything is working. If we click check results, you can see that that is locked, meaning there is another issue in the environment, even though the connectivity is working on all of these PCs. And again, you can see I can ping out to 203.0.113.27. It works on PC1. Let's check PC2. Again, we just did this. It works on PC2. PC3, it works. PC4, it works. PC5, it works. PC6, it works. And PC7, it's going to work. So we have an issue here in the environment that is not impacting our connectivity. So this is the question of where do we begin? So we take a look over here at the diagram that we have configured, and knowing that all the connectivity is working, it makes it a little bit difficult. And so here's what we're going to do. Now we're going to kind of do the troubleshooting method, which is sort of like taking a stab in the dark, right? Is we're going to get onto the devices where we think there could be an issue. And I'm going to come back here to the hub router. And so let's telnet to 168.0.1. And let's go Cisco and class. And let's just say show run here and take one last look at this router. And so that interface out to the ISP router is correct. So serial 010, that's a /30/30/30/30. So those all look correct. So 1, 9, 5, and 13 connected to factory. And I doubt that the problem is a typo in the description, even though connected is misspelt there. I'm hesitant to say that that is worth 20 points in this activity. However, let's make sure we eliminate that serial 020, interface serial 020, and the description would be connected to HQ. And again, I will be shocked if that is 20 points. And it's not. And I, again, did not think that it would be. But we'll go ahead and fix that anyway. The OSPF configuration looks correct here. What about a show IP OSPF neighbors? OSPF neighbors. And everything looks good there. Okay, show IP, whoops, sorry. How about a show IP route? And everything looks good there, and we have all the connectivity that we need. And I was convinced that it would be something. All right, and so the access list is allowing 192.168.0, and we're doing what would be a 255, 255, 250, I'm sorry, 248.0. So we're allowing a very large pool of addresses to get connectivity out to the internet. And so this one is a head scratcher here. IPNAT inside source list 1. That looks good. The pool, a /27. Let's see. So let's just work that out to make sure that we're not using pool addresses that, and it wouldn't allow us to put the command in. But again, if it is a /27, we've borrowed 3 host bits, meaning there are, I'm sorry, we've borrowed 3 host bits for subnet bits, meaning that there are 5 host bits at the end. And so 2 to the 5 is 32, which is going to be my block size. So the first network would be .0, and then it would be .32. And so we would work our way up here to .64, and then .96, and then what is that going to be? 118. Is that right? Plus 32, is that what that would equal? I'm sorry, 128. And so, yeah, we've got, after 128, if we added 32, to be 160. And so we are definitely in the /27 range. And again, the iOS would not allow you to enter that, but I'm just double checking to make sure here. So it looks good there. And again, we're meeting all of the requirements. So where else might there be an issue? Let's check the sub-interface configurations. The HQ router, we never logged on to the HQ router. So let's check out the HQ router, and who's connected there. We'll do the easy one, PC5. So let's telnet into PC5 VLAN 10 is 5.129. So 192.168.5.129 Cisco, and then we'll get into privilege exec with class. And let's just go ahead and say show IP OSPF neighbor. So we see that. That looks good. What about a show run here? And let's just take a quick walk through. So we've got our sub interfaces, .1, .5, and .10. So 6.1.5.1 and 5.129. 6.1, 5.1, and 129. So those all look correct. And the subnet mask lengths are correct. And the .1Q configuration is correct. And so let's take a look at these OSPF statements here. So 128, a /30, a /24, and a 128. Oh, and for the subnet mask, so /25. The .127 would be a /25. And so that looks correct. So the hub router looks good. Let's get on to the switches here. Maybe there's an issue on one of the switches. So from PC5, we'll start here at 6.254. So let's get out of here and say 6.254. And again, just reading through the description, it's not clear where the other issue might be. So let's go ahead and say class, and let's just say show IP interface brief. So we should see the 2 port channels are up. and the fast Ethernet 01 is up. Here are the port channel interfaces. Those are all up. And let's go ahead and say show ether channel summary. Maybe it's an ether channel issue that we have here. Well, if it is, it's not on this switch. Let's do a show run. And this switch looks good. All right, so let's go ahead and log off of this switch, and let's get over to Telnet 192.168.6.253. And we'll get into privilege exec. And let's say show ether channel summary. Maybe there's an ether channel issue of some kind here. And the ether channel looks great right there. Show IP interface brief. And everything looks good on HQ2. So let's go over to 52. Cisco, oops, sorry, CISCO. And we'll get into privilege exec with class. Show ether channel summary. And everything looks good there. What about a show VLAN brief? So we're good on that. And fast Ethernet 01 on HQ1. And hold on a second there. So fast Ethernet 01 is not even connected to the admin VLAN. So there's nothing connected. What about a show MAC address table? Let's see what we've got here. So you'll notice that fast Ethernet 01 is in VLAN 10, and I'm wondering if that is the issue. Because as you can see, switch HQ1, which is the switch that we're clearly on here, is showing that fast Ethernet 01 has been configured. And is that show IP interface brief? Is that fast Ethernet 01 up? And it shows that it's up, but there's nothing plugged into it, or nothing should be plugged into it. So this is interesting. All right, so we may have stumbled upon where the problem resides. So fast Ethernet 01 is up, but on HQ switch 1, fast Ethernet 01 is not being used. It's gig 01 is our router on a stick port. So this is interesting. So let's take a further look at this. So if I say show MAC address table, we can see fast Ethernet 19, 23, and then there's gig 01. And the reason that gig 01 is showing up here is because that is our router on a stick port. But then we've got 19 and 23. Let's see here. So something is not right. And take a look there at the fast Ethernet 01 interface is configured, but doesn't need to be. And let's look here. Group 1 mode active, mode 3 active. And let me go back up here and make sure that everything is switch port mode trunk for both of those. So that's correct. So fast Ethernet 01. All right. I would be shocked if this is it, because there's really no way interface fast Ethernet 01, no switch port mode access. Or actually, we'll say switch port mode dynamic desirable. Where's the conflict between no negotiated and no switch port access VLAN 10? And let's check this port again. Okay, so switch port mode access. And then no switch port mode access. Apologize there. Let's see. Rejected interface must be configured to the access or trunk modes to be configured to no negotiate. All right, so switch port mode trunk. And let's see if I got that. And then switch port mode dynamic desirable. No conflict between no negotiate. So that's not even giving us the points anyway. And there's an easier command that I would typically use, which is, and I don't know if it's going to be here, default interface fast Ethernet 01. All right, now let's see, do show run. Instead of trying to pull those things out individually, if I just wanted to wipe it out, I would say switch port, let's see, interface fast Ethernet 01, and we'll say no switch port mode trunk, see if it lets us do that. Okay, so yeah, so I don't think that's the issue though. So here's what I'm going to do. I'm going to pause, and then I'm going to sweep through the environment here and see if I can't identify where this final problem is at, and then we'll wrap things up. So I will be right back. All right, so this should be an interesting one. I literally just spent the last 5 or 10 minutes walking through every single PC, every single switch, and now I'm looking at the routers, and it was when I came to the factory router. That's the router that I'm on right here, is the factory router. And we resolved the issue with the IP OSPF 10 Area 0 advertising that 192.168.4.1 network. However, when I looked at this, the first thing that popped into my head was, you know what? I wonder if Packet Tracer is not configured, no IP OSPF 10 Area 0. I wonder if Packet Tracer is not configured to give me the points, because you'll notice we didn't lose any points right there, and Packet Tracer is notorious for doing this. It's not what Packet Tracer is looking for. And so we had the technical fix, right? Router OSPF 10, we had the correct fix, but we didn't have the network statement that would require to get the 20 percentage points. And so there we go. That is going to do it. So it was correct. When we had all the connectivity working, we were done. However, Packet Tracer never gave us the percentage points, the points for the IP OSPF 10 Area 0 command on the factory router for the missing subnet. It wanted the network statement. So that is it. That is going to do it for all of the activities that are part of Packet Tracer, I should say, the ESNA version 7 course from Cisco. And this is Packet Tracer Activity 12.6.2, the Troubleshooting Challenge. All right. Thank you so much for watching. Appreciate your time. Hopefully, through all of these tutorial videos, you've been able to learn a little bit about networking, and you feel a little bit more comfortable and confident with your skill set. That's it, guys. That's all I've got. So Packet Tracer Activity 12.6.2, this is the last of the ESNA Packet Tracer activities. Good luck to you in your studies, in your career, and have a happy holiday season, and I hope to see you in the next video.